Okay, we're back. One more example in trig. I can do more if you request, but for now this will be my last example. And also in this video, I'll do some theoretical stuff. What do we got here? 4 to the 2 log 4 tan x. Okay, so this one's a bit of a trick question. Okay, remember, if I have e to the ln x, that's just x. But also, if I have 4 to log base 4x, that is also just x. So I'm going to use that fact to make my life easier. So no trig, no calculus yet, just algebra. I can write this as 4 log 4 tan x. Now where does that 2 go? Well, that 2 has to go to the outside here. This is a rule here. A to the power of b to the power of c is a to the b times c, or a to the c times b. So I'm using this guy sort of in reverse to get this thing here. Okay, the whole point of that is to get the 4 and the log 4 beside each other because they cancel. Okay, finally I will do some calculus. I know you're getting anxious to see some calculus, so here we go. Chain rule, 2 comes down, and then I have derivative of tan, which is secant squared x. This is formula 3a from 12.3. And that's pretty much it right there. Now, you could try this again from the beginning and, not do all this. And I think you'll see it is an unpleasant business, but maybe a good exercise in its own way. Okay, finally, let's do a little proof here. Prove that sine x prime, is cosine. Okay, just to give you an idea of how these go. So we'll start by letting f of x equal sine of x. And then f prime of x is our formula for the derivative. Which I copy out from memory. What next? All right, what is f? F is sine, so get sine of x plus h minus sine of x. Oh, EV. Sorry. Now what? Now I'm going to have to use a fancy trig formula, which I do not have memorized. Sine of, a plus b is actually sine a cos b. Plus cos A sine B. So I'll use that on my sine of x plus h. Now what? That's a good question. What do I do now? I feel like I got these three terms on top. I got to arrange them in some way. Well, I got a sine x here, and I got a sine x right there. Why don't I put those two terms beside each other? So I put the two red terms beside each other, this one and this one. This guy went here, this guy went here, and then this buddy, different color. This buddy I'm going to put, over here. And this is h goes to 0, right? H goes to 0. So sine x can actually come out. It does not depend on h in any way, shape, or form. So limit cosine of h minus 1. I'll divide by h. Plus cosine of x times this limit. Okay, now where am I now? Well, unfortunately, this is where I have to invoke some magic. This limit is equal to 1, and this limit is equal to 0. Okay, the magic, I can't really go into the proof of these. These require, careful geometric arguments to demonstrate. But what happens is I get 0 plus just cosine of x. Giving me a cosine of x. Okay, and those limits here, again, they might be in your textbook, but these are certainly available upon request.